Okay, this is a pre-video for section 3.6 on quadratic functions. Just to get us a little bit more caught up, we're going to go through the first type of problems in this section, and then we'll leave the rest for class tomorrow. So the big thing is, I'm just going to point out some things here. Before, we have been talking about equations, and to be quadratic, remember you have to have a highest power of x squared. This is actually in what we call standard form of the equation. Notice that we have ax squared plus bx plus c. We've already seen this once before when we did quadratic formula. So for us, to make this a quadratic function, first of all, it has to pass the vertical line test, and we've graphed some things that are quadratic, and we notice that they have this U shape, either right side up or upside down, and so there they do pass the vertical line test, so then we can call the y f of x. So this is what we talk about when we say we're talking about a quadratic function, and that is the standard form for that, where remember f of x is really just the y. So the things that we'll want to do is that if we're in this format, we can easily use quadratic formula to find the x-intercepts. We could plug in something pretty easily to do a table of values, but none of that will give you the lowest or the highest point of the parabola very easily unless you already know kind of where it's located. So there's a couple of different ways we're going to show you how to find the point that is the highest or lowest, which is called the vertex. And one of them is by just manipulating the equation that we were given in standard form into something called vertex form. So this is the vertex form of the quadratic. Okay. Things to note about vertex form. It looks like something has been squared, which anytime I see that, I always think, oh, it's going to have something to do with completing the square, and it does, so I'll show you that in a minute. But essentially you have this A in front. The A is going to tell you if your parabola is right side up or upside down, depending on if it's positive or negative, and we'll talk about that in a minute, actually probably tomorrow when we graph. And then the vertex is pulled out from this H and the K. The vertex here is the H and the K that you see listed when we're in vertex form. So the vertex, notice that inside, this kind of goes back to transformations. It's a minus h in the formula. When we write it out, we actually write positive. You write the opposite of what you see in the parentheses. And the k is positive out here, and we write exactly what we see. So notice it's opposite of the sign inside and exactly the sign on the outside. So that's how we get our vertex. So if you can get into this format, you really quickly have the highest or lowest point of your parabola just staring at you in the formula. So how do we do that becomes the harder question. So to be able to do it, we have to complete the square, but it is essential that we factor out any coefficients in front of x squared that are not a 1. Remember, when we do completing the square, big thing here is that we need x squared to have a 1 in front. So I'll do one first of all that's already set up, and then we'll show you one where you have to actually move that coefficient to the front as a GCF. Okay, so I'm going to actually just jump down, and by the way, once you're in vertex form, you can use transformation of functions to graph your parabola, so that's a nice thing there. Now, I don't like that they call this the standard equation because it kind of makes you think standard form. Our book calls it the standard equation of a parabola with a vertical axis. Most textbooks I've seen call it vertex form of the equation. So I don't know why our book is different, but it just is. So then let's look at this very first one here. So we want to put this in the form f of x equals a x minus h squared plus k. To go from standard, so to go from standard form to vertex, we should complete the square. Okay, so let me talk you through a very easy one, and then we'll do one that's a little harder. So for this guy right here, Notice when you complete the square, you wanted to focus on the x squared and the x part, and you kind of ignored that plus 11. In fact, we moved it to the other side, but we're dealing with a function right now, so we don't know if we really want to move it to the other side. That is one way of taking care of it, but there's a way to do this with leaving it on the same side. So I'm going to show you that. So the first thing I do is I leave a space for completing the square of that trinomial. Then I write over here a little bit of a space so I can focus on this, plus 11, and I leave a second blank. Normally our two blanks would be one on each side of the equation. If you do them both on the same side, they have to have opposite signs because essentially they need to cancel each other out. So if this is like a plus 7, we would need that to be a minus 7, except it's going to be a little bit more complex than that when we get to the harder ones. But essentially, if you keep the two blanks on the same side, they need to cancel each other out addition-wise. So let's complete the square on this piece right here. So this is the trinomial that we're trying to complete the square on. So remember, when you complete the square, you take half of the middle term, and then we square it. So that is -3, and then we square. So that would be positive 9. Okay, now I'm going to go ahead and write that over here. So f of x equals x squared minus 6x plus 9. So that's, let me make that in red. So this is plus 9. So I added that in. And then in my original equation, I after that had a plus 11. And because I am trying to keep my equation balanced, since I'm keeping my blank on the same side, I do a minus 9. Now I'm not going to cancel the two numbers out. That defeats the purpose and takes us back to what we got. But at least we know that this is balanced. The equation really hasn't changed that much. So the next step is to factor the trinomial up front. So that factors into x minus 3 and x minus 3. So that would be x minus 3 squared. And then you add or subtract these two numbers together. So that would be a plus 2. So in vertex form, this is one where you have a 1 in front for your a, and your vertex, because you can read it now right off of this format, is the opposite of the sign inside the parentheses. So that'd be a positive 3, and exactly what you see outside. So if I wanted to graph this quadratic, I would know that in fact, the lowest point, since this is a positive 1 up front, it's going to be up. If a in front is greater than 0, your parabola opens up, and if a is less than 0, your parabola opens down. So since we have a positive 1, we're opening up, and the lowest point then of that parabola would be 3, 2. So you already know quite a bit about the graph. Okay, let's do one more. Let's do one where we have, or maybe two more. Let's do one where we have a number out front that is not a 1. So for example, b. In b part, again, we're separating this out to complete the square where we keep the x's together and we move the 17 a little bit behind it so that we don't focus on that right away. So I'm going to keep the 5x squared and the plus 20x, and then I'm going to leave myself a blank, plus 17, and then I leave a second blank to counterbalance that. When you're doing completing the square, you have to have a 1 in front of your x squared. So we need to pull a 5 out of just the trinomial that we're working with. So it's like kind of like factor by grouping. You're only pulling it out of a part. So this would leave me with an x squared plus a 4x, and we don't even know what this number is, so it's still a blank. And then we still have our plus 17 and our blank. Okay, so then we need to do half of our middle term, so we can figure out what to add and square it. So 4 divided by 2 would be 2, and when we square that, that would be a 4. So we definitely are going to write a plus 4 in here. This is where things get a little bit tricky though, and you have to just pay close attention to what you're doing. This is 5 parentheses x squared plus 4x plus 4, which I'm going to do in red again to show that that's what I added in. And then outside, I would still have my plus 17, but in my second blank, I am not going to put minus 4. That would not be balanced. You actually have a distributive property here. We didn't really add 4. We added 5 times 4, which means we really added 20. So if we added 20 to this problem, because it's this number times this one, to balance that we need to subtract 20 from the same side. So it's actually going to be minus 20. Okay, so then to finish this one out, we would have f of x equals 5 parentheses. Remember, this factors nicely into x plus 2 times x plus 2. So that's x plus 2 squared. 17 minus 20 is negative 3. So this vertex, if I needed to state the vertex, would be opposite of the sign you see inside. So that'd be negative 2, exactly the sign you see for the k. So it'd be negative 3. Okay. Let's look at part C. So this one's a little bit different because we have a negative up front to pull out. Let's see how that changes things. So we're going to keep our x's together, create a space to complete the square, bring down the minus 13, create a space to do the counterbalance. We need to pull out that negative 4 because we have to have a 1 in front to complete the square. That will change some signs. That's going to make that x squared. That's going to be a minus 4x. We don't even know what the blank is, so we're just still a blank, minus 13, and our blank. We need to take half of the middle term, so half of negative 4 would be negative 2, and then we square it, so that would be 4. And remember, be careful here on our next step. So this is f of x equals negative 4 x squared minus 4x, change to red so I can highlight what I'm doing. Yes, I am adding 4 inside. Bring down my minus 13, but I have to be careful. I am not going to be doing the opposite of positive 4 here. I have to also consider the GCF out front. So I really did negative 4 times 4, which is negative 16. The opposite of that would be positive 16. So I need to make sure I do the opposite of what really happened in this distributive property. So then this would be f of x equals negative 4. This factors into x minus 2 and x minus 2, so that'd be x minus 2 squared. And then add those two together and get positive 3. So my vertex is 2, 3. Opposite sign of the parentheses, exactly the sign of the outside. And this is a parabola that would actually open down because you have a negative out front and your A. Remember, a positive A would open up, a negative A would open down. So this actually is the highest point of your parabola. Your parabola would look like this with 2, 3 being at the top. Okay, so that takes care of converting from standard form to vertex form. Let me make sure I circle my answer right. Plus 3. There we go. I'm going to look at this next one down here. These two I think we can also do on the video. And then we'll leave some of these for in class. And plus I'll probably do an extra one of the vertex form just to make sure we're good on that. So this is saying find the standard equation of the parabola. Remember, standard equation depends on what they mean by standard, because to me standard means ax squared plus bx plus c. So we want to see what we know, and we can use this formula of vertex form to help us find the different pieces. So if you have your vertex, you have your h and your k. An x-intercept of 0 is 0, 0. That is not A, but that is an ordered pair. So we can plug that in for the x in the formula and the f of x, because remember that's an x and a y. So if we plug in what we know, this would be 0 equals a parentheses 0 minus h, which would be minus 2 squared, plus k, which is 4. I would subtract the 4 over to the other side, and let's work out this parentheses. That'd be negative 2 squared. So that would be 4. And if we divide by 4, we get negative 1. So now I know that my equation in vertex form would be f of x equals negative 1 for a, parentheses x minus the h, which is 2, squared, plus the k, which is 4, and we leave x and f of x as variables. So that would be vertex form. If you want this in standard form, you need to FOIL this out and distribute the -1. So we would do x minus 2 times x minus 2, which gives me x squared minus 4x plus 4. I would distribute my -1 out front. That would be negative x squared plus 4x minus 4 plus 4. The -4 and plus 4 cancel. So for standard form, I'm getting just negative x squared plus 4x. So f of x equals negative x squared plus 4x. So that is both formats, just using a vertex and an ordered pair. Okay, I think that's a good place to end the pre-video. So what we'll do is I'll probably do one more completing the square, and then I will do one or two more where we do the 2 points, and then we still have to talk about the graphing and max and mins and how to find the vertex without using vertex form or completing the square essentially. So we have a few more things to do, but we should be able to get through at least one of every type tomorrow in class.